Hi everyone. I want to treat a question in a meter bridge instrument, okay? Or in a meter bridge practical, right? In physics topic. This is very essential in electrical field. But if you want to pass your physics or you want to study electricity in any of the high institution, you need to know this topic, right? And you need to pass your physics, okay? So that's why I'm treating a question from the meter bridge. Remember that the last question I've solved, I mentioned about two of them. I mentioned about Weston Bridge and meter bridge. Weston is a theoretical form of this meter bridge, while the meter bridge here is a practical form of Weston Bridge. Okay, so last question I solved was on Whetstone Bridge. But now, in this one now, is question from meter bridge, okay? So listen, it's very, very interesting. Remember I said that it's used to know the accuracy of resistance in electrical field, right? So make sure you pay attention and learn how to solve this. Or if you are a physics lover or you are a lover of electricity, you can pay attention and watch. Direct your younger ones to it that are writing the exam, okay? So now let's move on and solve that. The question says, this is the diagram of meter bridge practical, okay? So this is the one of the two resistors, resistor one, resistor two, okay? This is constant wire or any stable wire for the experiment, which is always, the length is always 100. The length from here to here is always 100. Make sure you know that, okay? So the resistors above, we have this one is 10 ohms, while this one is the one they ask you to calculate for. We need the value of this. So we need the value of this, right? Now the question says, in a meter bridge experiment, right, is a zero, in a meter bridge experiment, there is a zero deflection of a galvanometer. We use G to represent the galvanometer, which is this one that is always connected to it, okay? When the length L1 is 40 cm. So we used to connect the galvanometer and the wire that we used to take the initial length, which is the length 1. So if we touch the length, we continue touching the length. When the galvanometer has no reading or reads zero deflection in the galvanometer, that is when we have the 40 cm, okay? And it is our length 1. So in a meter bridge experiment, there is a zero deflection of galvanometer when we have our length 1 to be 40 cm as shown in the diagram above. We now say that we should calculate the value of the resistance R. So we are now going to calculate the value of this R, okay? So this is the instrument. The first R is already here. We are now going to measure the second R when we detect the value of our L1. The formula is R1 all over R2 equals to L1 all over L2, okay? So our R1, which is the resistor 1, is this, and our resistor 2 is this, which we will measure in this experiment. Then our L1 is the 40 we have gotten here. Then we are now going to subtract the 40 from the total length, which is 100. We now have 60, okay? And that remaining 60 will be our L2. So let's fix our values. R1, which is the first resistor, which is 10, all over the one we need equals to the length 1, which is 40, all over the longitude, which is 60, when we subtract 40 from the 100. We now do cross multiplication. The resistance R we are looking for times 40 will be 40 resistance. Okay, that is the resistance we are looking for, equals to 10 times 60 is 600. We need this, right? We now divide both sides by 40. So 40 kill 40, remaining only the one we need, equals to now 600 divided by 40. 40, 0 kills 0. And now remaining 60 divided by 4. Now 4 divide 6 will give us 1 remainder 2. We now take the 2 in front of this 0. The remainder, it will now be 20. We now say 4 divided 20. It will now get 5. Okay. So now, when 600 is divided by 40, the answer gonna be 15 ohms. The answer will be 15 ohms. So that is the value they ask us to calculate. Can you see that the calculation is very simple? Okay, you just to know the formula, then apply it, you get that, right? So thank you so much for watching. Please make sure you comment, share, and like the video on any of my social medias: Facebook, YouTube, TikTok, Twitter, and Instagram. Okay, thank you so much for watching, and God bless.